Disasters strike fast. Sometimes without warning. Other times, even with all our science, we miss the signs. So, why are disasters so unpredictable? It begins with their very nature. Disasters aren't just events, they're complex systems unfolding in real time. From an earthquake shaking a city to a cyber attack crashing national infrastructure, the causes are layered, often invisible until it's too late. Disasters fall into three broad categories. Natural, like hurricanes, tsunamis, wildfires. Man-made, think industrial accidents, chemical spills, power grid failures. And hybrid disasters, where human activity triggers or amplifies natural forces. Climate change-induced floods. Infrastructure collapse after heavy rains. These hybrids blur the lines and complicate prediction efforts. The web of causes is tightly knit. One weak link, one overlooked variable, and the dominoes start falling. That's the challenge: interconnectedness. Every disaster is a ripple through systems, ecological, technological, societal. The complexity makes even the most advanced forecasting feel like guesswork. But the tools are getting sharper. Artificial intelligence and machine learning are transforming how we analyze risks. Massive datasets, once too overwhelming to interpret, now reveal patterns. Clusters of tremors hint at bigger quakes. Shifts in ocean temperature foreshadow hurricanes. Algorithms spot the signals buried in noise. When it comes to earthquakes, systems like the USGS ShakeAlert or Japan's earthquake early warning system use a network of seismometers that detect the first pressure waves, P waves, before the more damaging secondary waves arrive. Though it can't predict earthquakes in the traditional sense, it can provide up to tens of seconds of warning, enough to shut down gas lines, halt trains, and save lives. Flood prediction relies heavily on hydrological models that simulate river flows, rainfall data, and terrain features. Remote sensing through satellites, like NASA's Global Flood Monitoring System, allows us to track real-time flood risks on a global scale. AI models process this data to identify high-risk zones and generate early alerts. Cloudburst forecasting is even trickier due to its hyperlocal nature. But high-resolution weather models, Doppler radar systems, and ground-based sensors are helping meteorologists capture sudden shifts in atmospheric pressure and moisture. Machine learning models analyze these rapid changes to flag potential microscale storm events before they happen. For hurricanes, the tech is more mature. Satellites like NOAA's GOES series constantly monitor sea surface temperatures, wind patterns, and atmospheric pressure to track cyclone development. Aircraft like the Hurricane Hunters fly directly into storms to collect real-time data, while supercomputers run predictive models, like HWRF and GFS, that simulate storm paths, intensity, and landfall impact with increasing accuracy. Historical data plays a crucial role too. The past leaves clues: recurring weather cycles, seasonal droughts, infrastructure wear and tear. By digging into history, we begin to map the future. Then there's the sky. Satellite imagery and remote sensing deliver a global view, tracking storm paths, monitoring deforestation, observing ice melt. Real-time environmental surveillance adds a whole new dimension to prediction. Still, forecasting is only half the story. The other half is response. Early warning systems are frontline defenders. Seismic sensors that detect the first rumble. Sirens that wail before the floodwaters rise. Push notifications, SMS alerts, automated broadcast interrupts. Every second matters. And with the right system, those seconds can save lives. But even the best system is useless without communication. Information must move fast and reach everyone. Language barriers, internet access, trust in the source, all play a role in whether people act in time. Where early warnings work, the results are undeniable. Fewer casualties, less damage. Communities with minutes of advance notice fare drastically better than those caught unaware. Yet, the real key isn't just predicting or warning, it's preparing. Disaster resilience starts long before the storm. Stronger buildings, smarter infrastructure, educated communities that know what to do when systems fail. Preparedness is power. And resilience isn't just local, it's global. Sustainable development practices, risk-aware city planning, and investments in climate adaptation create a safer world for everyone. So what does the future hold? Predictive models are growing smarter. Quantum computing, edge sensors, real-time AI models, they're all pushing boundaries. We're seeing the rise of integrated multi-hazard platforms that combine data from weather stations, seismic monitors, satellites, and social media feeds to create holistic risk maps in real time. But with progress come questions. Who owns the data? Who decides who gets warned? How do we ensure equity in protection? The dream is clear. A world where disasters don't catch us off guard. Where science doesn't just react, it anticipates. Where humanity doesn't merely survive the storm, but outsmarts it. Prediction is no longer science fiction. It's science in action. And it just might save the world. If you are enjoying the content, please hit that like and subscribe button to support us in making more such content. You can share your views below in the comments as well.